Welcome to second part of examination quiz on welding metallurgy covering material and their behavior to help you to clear International Welding Engineer or International Welding Technologist or AWS-CWI or CSWIP examination. This worksheet contains 40 questions. Each question carries 1 mark. The answers are shown at the end of the examination. Please use a paper and pen to write down the correct answer. You shall grade yourself at the end of examination matching your answer. The grading will show your current level of knowledge in the welding metallurgy and material and their behavior module. Question 1. Destructive tests of welds are designed to A. Determine the mechanical properties, that is tensile strength, ductility, toughness. B. Determine the modulus of elasticity of a weld metal. C. Calculate the percent of reduction in area for an all-weld metal specimen. D. Determine the soundness of weld metal. E. All of the above. Question 2. Which test is not considered a soundness test? A. Hardness. B. Face bend. C. Fillet break. D. Root bend. E. Neck break. Question 3. Which of the following is not a method used to eliminate or reduce residual stresses? A. Vibratory stress relief. B. External restraint. C. Thermal stress relief. D. Peening. E. Annealing. Question 4. When the weld structure is to be examined at magnifications over 10x are used? A. Macro specimens. B. Micro specimens. C. Tensile specimens. D. Charpy specimens. E. Chemical tests. Question 5. A welding performance qualification test serves to A. Determine a welder's reliability. B. Determine the mechanical properties of a weldment. C. Provide statistical input for the purpose of estimating the ratio of accepted-rejected welds. D. Determine the welder's ability to deposit or produce sound weld metal. E. All except C above. Question 6. Hardness of the base metals can be affected by which of the following conditions? A. Heat treatment. B. Cold working of the metal. C. Composition of the base and weld metal. D. Metallurgical effects of the welding process. E. All of the above. Question 7. Rapid quenching of steel from the austenitic range results in a hard, brittle structure known as A. Pearlite. B. Carbide. C. Cementite. D. Ironite. E. Martensite. Question 8. A stress relief heat treatment, approximately 1150 degrees Fahrenheit on carbon steel, is intended to A. Change the microstructure of the weld. B. Increase the tensile strength of the weld. C. Reduce the residual weld stresses across the weld. D. Increase the impact strength of the weld. E. Provide a method of oven heating for the removal of gas pockets trapped in the weld. Question 9. For a steel having a chemistry of 0.16% carbon, 0.84% manganese, 0.09% nickel, 0.25% chromium, 0.025% copper, and 0.40% molybdenum, what is its carbon equivalent? Use formula for CE calculation given below. A. 0.23. B. 0.34. C. 0.37. D. 0.41. E. 0.46. Question 10. The upper limits of preheat and interpass temperature for quenched and tempered are specified for what reasons? A. Keep deposit rate to a minimum. Maintain the strength in the base metal heat affected zone. C. Keep the weld metal from becoming too strong. D. Avoid cracking in the weldment. E. Both B and D above. Question 11. Solid metals are blank in nature and all have a structure in which the atoms of each crystal are arranged in a specific geometric pattern. A. Amorphous. B. Crystalline. C. Homogeneous. D. Non-homogeneous. E. Both B and C. Question 12. The portion of the base metal has not been melted, but whose mechanical properties or microstructure have been altered by the heat of welding is called the A. Heat affected zone. B. Fusion zone. C. Hard affected zone. D. Weld interface. E. Base metal. Question 13. The primary purpose for preheating carbon and low alloy steels is A. Improve mechanical properties. B. Increase hardness. C. To reduce the distortion. D. To reduce the tendency for hydrogen-induced delayed cracking. E. Both A and C. Question 14. The primary reason for post-weld heat treatment, PWHT, is to A. Relieve the residual stresses in a welded fabrication. B. Maintain the hardness level. C. To reduce the tensile strength. D. To increase the yield strength. E. To eliminate the hydrogen-induced cracking. Question 15. Sensitization of stainless steel primarily refers to its loss of A. Strength. B. Toughness. C. Ductility. D. Corrosion resistance. E. Impact resistance. Question 16. What must be done to steels before welding and after welding if they contain more than 0.40% carbon? A. Weld without preheat, no PWHT required. B. Preheating and subsequent heat treatment. C. Only preheat is sufficient. D. No preheat required but PWHT to be followed. E. None of the above. Question 17. Why are high carbon steels preheated before welding? A. High carbon content will reduce yield strength and required to be preheated before welding. B. Preheating is not required for high carbon steel. C. Because of the high carbon content, the heat affected zone can transform to very hard and brittle martensite. D. Because of the high carbon content, the heat affected zone can transform to very soft and ductile pearlite. E. Both A and C. Question 18. High carbon steel is characterized as having what type of weldability? A. Very good weldability. B. Not weldable. C. Good weldability with small process. D. Good weldability. E. Poor. Question 19. Why must cast iron weld filler metal be ductile? A. It must yield as the weld cools and shrinks because the cast iron cannot yield. B. It need not to be ductile as cast iron is easily weldable. C. The filler metal need to be ductile so it can provide high tensile strength. D. It must not yield as the weld cools and shrink because the cast iron is ductile. E. Both A and C. Question 20. What factors other than carbon affect a steel's ability to be welded? A. Yield strength of the material. B. Thickness and geometry of the weld joint. C. Carbon is the only element affect the weldability. D. Nickel in the base metal. E. None of the above. Question 21. Precipitation hardening stainless steels are: A. Having equal strength. B. Having much less strength than austenitic steel. C. Stronger than austenitic steel. D. Not fall under the stainless steel classification. E. None of the above. Question 22. What does the term weldability involve? A. Welding process, metal transfer mode and base metal. B. Thickness and geometry of the weld joint. C. Joint design. D. The metallurgy of the metal and filler metal. E. Heat treatments before and after. Question 23. What properties does chromium produce in stainless steels? A. Tensile strength. B. Hardness. C. Corrosion resistance. D. Toughness. E. Both A and C. Question 24. What is the importance of carbon equivalent for welding? A. It helps to decide the welding process to be used. B. It serves to determine the electrode diameter during smoke. C. It helps to determine the amount of preheating temperature. D. It serves to decide the material weldability. E. Both C and D. Question 25. What is the atomic structure found in carbon steel at room temperature? A. Body center cubic. B. Face centered cubic. C. BCC. D. FCC. E. Both A and C. Question 26. Which are the right answer concerning the pearlite? A. The carbon content is always 0.4%. B. Pearlite is mixture of ferrite and cementite. C. Pearlite is mixture of ferrite and austenite. D. The carbon content is maximum 0.8%. E. Both A and B. Question 27. A high cooling rate in steel will produce: A. A very fine ferrite and pearlite. B. A wide lamellar pearlite. C. Binite and pearlite. D. Has no influence on the material structure. E. None of the above. Question 28. What kind of information does a TTT diagram gives? A. Solidification temperature. B. Phase transformation time. C. AC3 temperature. D. Content of structure after cooling. E. The hardness of weld deposit after cooling. Question 29. What is the effect of manganese in steel on alloying? A. Manganese increase the toughness. B. Manganese reduce the hardness. C. Manganese increase the strength. D. Manganese have no influence on material properties. E. Both A and C. Question 30. Which heat treatment is shown in the figure by green area? A. Coarse grain annealing. B. Hardening. C. Tempering. D. Normalizing. E. None of the above. Question 31. Which heat treatment is shown in the figure by red area? A. Annealing. B. Hardening. C. Tempering. D. Normalizing. E. Both B and D. Question 32. The hardening heat treatment follow. A. Heating, holding and slow cooling. B. Heating, holding and very fast cooling. C. Heating and air cool. D. Heating, holding and furnace cool. E. None of the above. Question 33. The diagram here shows A. Annealing process. B. Normalizing process. C. Quenching process. D. Spherodizing process. E. Quenching and tempering process. Question 34. The diagram here shows A. Annealing process. B. Normalizing process. C. Quenching process. D. Spherodizing process. E. Quenching and tempering process. Question 35. CTOD test stands for A. Crack toughness overlay density test. B. Crack tip opening displacement test. C. Crack tip open displacement test. D. Cathodic tungsten opening displacement test. E. None of the above. Question 36. NDT in material science stands for A. Non-destructive testing. B. Non-destructive temperature. C. Nil ductility temperature. D. Nil destructive test. E. Non-ductility temperature. Question 37. Which heating method is fast in application? A. Induction heating. B. Resistance heating. C. Flame heating. D. Heating in sunlight. E. None of the above. Question 38. Which diagram here represents the coarse grain? A. B. C. Both A and B. D. None of the above. E. Not applicable. Question 39. Identify the microstructure in the given picture. A. Martensite. B. Bainite and pearlite. C. Ferrite and pearlite. D. Primary ferrite and acicular ferrite. E. Austenite. Question 40. Which welding processes can be considering as surfacing process? A. Weld buildup. B. Weld hard facing. C. Cladding. D. Buttering. E. All of the above. Here, the answers are given. Please mark your answer and check your rating. Best of luck.